There. Okay, you should to see a picture, yes? This an experimental setup. This picture show us two device manometers. There are left one, an echelon, and right one in question. And we can adjust this angle here. And there is a source of pressure. Manometer connected with two sides. This side seen with tube connected with pressure source, and this pressure lower than ambient pressure. And this side opened, and there are ambient pressure. So when we move this part, we lower pressure in this chamber, and level of fluid in this tube changes because difference of pressure from chamber and ambient pressure. And when we move this part, pressure decrease and water level, or not water, these manometers use spirit, and level of fluid increase. And we have three sets of data. You must see Excel, yeah? First set of data, second set of data, and third one. All numbers level of fluid in tube. So when we change pressure, fluid rise, and level of fluids in millimeters from starting point for difference 0, 0 level, 10, 50, 70, so on. And there are two columns here. First for left one and second for right one. And we have all sets have two tables here. First tables with known angle. We have 83 degrees for both columns, yeah? But in second table, we don't know angle. We need to find this angle. So in variant 2, different angle. 90 degrees vertical tube. In variant 3, also different angle. 45 and 30 and 45 and unknown angle. And aim of this work to find this unknown angle. How we able to find this angle? First one, we have relation. This relation, this formula, yeah, you should to see. This formula related change in difference in pressure. So difference in pressure between this chamber and ambient pressure. This difference in pressure related to this formula. This formula for left one and this formula for right one. Gamma E and gamma G is the density of fluid, and we know this density 0.8095. This value in brackets A minus A0. This is data from table. This for left and this column for right. Sinus phi and sinus phi is an angle phi. And K, this is a coefficient. These coefficients related to change in density unknown for us. This coefficient related to different additional effects that make data so unreliable. because if coefficients equal to 0 in both cases, we have equal data in table. But we have small difference, 10, 11, 70, 72, and these coefficients related to this difference. And we need to find coefficients. We impose it for first one that k equal to 1 to unit yet, yes, but we need to find second one coefficients. And we have such formulas. This just related previous one, and this formula kg equal, and this exactly left part of formula divide by second part of formula without k, and we can calculate k for each table. So we need to calculate k for first sequence of data. How we do it? First, we can change this brackets value by tangent theta. What does this mean? We need to plot a graph. In Excel, I have in Russian Excel, but we have maybe English. It's very simple. Yes, and I have a graph. First one, I need to swap X and Y. Yeah, because I need horizontal axis to known etalon manometers and vertical axis to unknown. And I do this swap just by moving frames. Yeah, I have a point, and I need to know tangent theta. This is the angle of line. So I use this option. AGD line of train. I use linear. I get show equation. I'm imposed to intersection in origin point. So I have a line, and I have a equation of this line, and I have a coefficients. 0.9771 is the coefficients in question. So I just write these coefficients in cell of Excel. Yeah. After, so I obtain this part of equation. Gamma A and gamma G equal values, and these cancel each other. And I have these coefficients. I impose it KE as 1, and I need to find these sinuses. If I know angle 83 and 83, it's very easy. I put sin. After, it's very important, I change from degrees to radians, because sinus function must work with radians. So I change into radians, and I have first sinuses and second one. It's exactly same values for variant 1 and for variant 2. But in variant 3, difference angle. And for variant 3, it's very important to get real values. So I know all components of this formula, and I can calculate k. So k equal tangents multiply by left and divide by right. So my coefficients equal to tangents because sinus equal, and coefficients of my manometers is 97%. From this formula, by rearrange of values, I can obtain also angle, this angle. So in these cells, I put value of sinus like this, and I need different tangents. For this set of data, I need same coefficient. I can do the additional diagrams. For X, I put these columns, and for Y, I put these columns. So I have a data of A to B lines. So and have second coefficients. Yeah, and for angle, I just need to put in this table this formula. Convert from radians to degrees. Just apply arcsinus function and put this tangents multiply by sinus and divide by these coefficients. And close all brackets. Here I obtain an angle of unknown manometers, 49.9. 50 degrees, it's the angle of unknown for this X value. So it's task for you to do this calculation and to find unknown values. This will be laboratoral work 1 for you. So I just give you this Excel table. I delete this formula. You can from recording to replace this all. And you need to find this X value for variant 1, 2, or 3. So, and back to protocol of laboratoral work, I show you an example. I have Russian protocol with like this. This is a photo. Yeah. Just tables, formulas, so on. Pictures. And you need to make two graphs in Excel and put this in protocol. Put this formula and values what you find for angle. Like in this case, angle 51. So I just send you these files with 3 tables and all formulas what you need. You just need to ADD graphs, find coefficients from graphs, and do all calculation in 2 formulas. Yeah, it's all. If you have any questions, you can ask now or ask in Telegram every time what you want. Any questions now or after? Okay, if you have no questions, I just end now and send you all files that you need for do this task.